Alright, in this tutorial right here, I'm going to show you how to solve logarithmic equations using algebra. Number 1, log base 2 raised to 3x plus 5 is equal to 5. Alright, so how would you solve this problem? So what we're going to do here to solve this problem is solve for x. What I'm going to do is I'm going to convert to exponential function. And I'm going to just use this formula where log base a to the b is equal to c. Alright, and to convert this, because that's in this form, what I'm going to do is I'm going to move the b and the c around and get rid of the log. So a to the c is equal to b. Alright, so what I'm going to do is I'm going to come over here real quick, and I'm going to identify with a, which is going to be base, right, of 2. B is what's going to be inside the parentheses, and then c is going to be 5. So what I'm going to do is I'm going to quickly just move these b and c terms around. So 2 to the 5th power is equal to 3x plus 5. Alright, so now this looks like an easier an equation. This is an exponential function, so this is going to be straightforward from now. If we follow PEMDAS, we can solve for x. So what I'm going to do is I'm going to quickly do 2 to the 5th power, which is 32. And I'm going to set that to 3x plus 5. Alright, so to solve for x, what I'm going to now do is I'm going to take away 5 from each side. So I can isolate 3x by itself on one side of the equation. So 32 minus 5 is going to be 27 is equal to 3x. Simply to solve for x, all I'm going to do is I'm going to just divide each side by 3. X is equal to 9. Alright, let's say that you have a problem that looks like this, where you have log base 3 of x plus 1 equals 3 minus log base 3 of x plus 7. Alright, so how would I solve a problem like this? So, when you see a problem like this, what you want to do is you want to get the logarithms and combine them on one side of the equation, and then be able to convert to exponential function. So what I'm going to do here is I'm going to move this negative log onto this side with this positive log, alright? So what's going to happen is it's negative on this side, but it's going to be positive on this side. So it's going to be log base 3, x plus 1, and it's going to be plus log base 3, x plus 7 is equal to 3. Alright, so notice how we have this property. And property of logarithms we're going to use in this example right here, it's going to be log A plus log B is equal to, and it's going to be log, and what's inside the parentheses, A times B. Alright, so that's the property of logs we're going to use in this example right here. So what I'm going to do is I'm going to combine these logs. This is log A and this is log B. Alright, so what I'm going to do is I'm going to combine it by just doing the property. So it's going to be log base 3, and it's going to be x plus 1 times x plus 7, because these have the same bases, right? So, and I'm going to set this equal to 3. So what I'm going to do is I'm going to quickly FOIL this. So this is what I'm going to do is I'm going to FOIL. So to FOIL this, I'm going to combine the first terms inside the parentheses, which is going to be x squared, and it's going to be x times 7, which is going to be 7x. 1 times x is going to be x, and then 1 times 7 is going to be 7. And I'm going to just convert this. So it's going to be x squared plus ax plus 7. And then it's going to be log base 3. It's raised to this. And I'm going to set that equal to 3. So I got that so far. So all I did is just did the FOIL right there just to simplify that. So now what I'm going to do is I'm going to be able to I'm going to convert it into its exponential function. So recall the property of logs where you have log base a to the b is equal to c. And then its exponential form is a to the c is equal to b. Because you convert and you move the a, or you move the b and the c around each side of the equation. So what I'm going to do is I'm going to move these two around, the b and the c. So it's going to be 3 to the 3rd is equal to x squared plus ax plus 7. Alright, so 3 cubed is going to be 27. It's equal to x squared plus ax plus 7. So now this is what they call a quadratic equation. So what I'm going to do here is I'm going to get, I'm going to set this right here to 0. So what I'm going to do is I'm going to subtract each side by 27. So it's going to be 0 is equal to x squared plus ax minus 20. Alright, so now what I'm going to do is I'm going to factor this expression. So I'm going to ask myself, well, what two numbers multiply to negative 20 but add up to positive 8? And it turns out that's going to be 10 and negative 2. Alright, because 10 minus 2 is 8, but 10 times negative 2 is negative 20. So I'm going to write two factors. So it's going to be x plus 10, and it's going to be x minus 2. And we'll set these each to 0. Alright, so x plus 10 is going to, x is equal to negative 10. And x plus minus 2 is going to equal, x is equal to positive 2. Alright, so a thing we might want to note here when solving this right here is you want to choose the positive value. Because if you have a logarithm, let's say if like negative n, right? It's going to be an undefined function. Because, and you can type this into the calculator. So if you type in like log of negative 10, you're going to get some undefined or no real solution. So you want to make sure you choose the positive solution. So therefore, x is equal to 2, and that's the real solution in this example. Alright, try this one. Log base x raised to the log base x is equal to 64. If you recall, there's a property of logarithms we could use to solve for x. Alright, so what I'm going to do here is I'm going to write that property of logs right now. So you see you have log base x raised to the n. The property of logs goes as following. What you do is you move the n in from the log. So it's going to be n log x. Alright, so I'm going to apply that to this problem right here. So what's going to happen is I'm going to move this log right here in front of that log using the property of logs I just showed you. So it's going to be log x times log x is equal to 64. So now log x times log x, well, you could say, well, that's just log x squared. It's equal to 64. Because you can combine these logs by multiplication, and it's going to be log x squared into a single log, which you want to do. So what I'm going to do is I'm going to take the square root of each side. Alright? So I'm going to get log x is equal to 8. Alright, so a property of logs we're going to also use, and when you have no undefined base or you don't have a base, it's understood to be 10. Alright? So, what I'm going to do here, and this should be plus or minus 8. So what I'm going to do here is I'm going to convert this into its exponential form now to solve for the values of x. So there's two possible values of x, because it's plus or minus 8. So what I'm going to do is I'm going to move the 10, or not the 10, I'm going to move the x and the 8 around each side of the equation and get rid of the log. So it's going to be 10 to plus or minus 8 is equal to x. Alright, so this being said, there's two real solutions in this problem because they're both positive, although one's going to be a really small number. So what I'm going to do is I'm going to write out the numbers. So 10 to the positive 8 can equal x, and then 10 to the negative 8 is also equal to x. Now 10 to the negative 8 is a very, very small number. It's not negative just because it has a negative exponent there. So that's how you solve a problem associated with log raised to another log.